So we want to make sure that whatever grade is posted includes everybody, everything that you want to include it. You gotta be kidding me. All right. Again, good morning. For those of you who just came in, we're doing the lessons in Canvas today. Pretty much stay in Canvas today and do the lesson on population and demographics. All right, so hopefully you've completed your assignment on Muskogee County. I know we had some issues as to getting to the website. Um, all right. One of the things I try to do with this class as well is because it is environmental science, I want you to feel like you are a part of the environment. And so you need to, as often as possible, I'm going to try to point out, where do you fit in? So we're not just talking about population and demographics in general. What is your population where you live? And where do you fit into that population? So that was the point of that question. So we're going to look at the vocabulary in particular and the activities on that page. All right, we got a good set of folks in. It is past the 5-minute mark. So again, go to that Canvas page. I'm going to go ahead and take attendance, and then we will discuss what is population. So that is the name of the unit. What is population? So we want to be able to define it and look at the different descriptive words that go along with talking about population. Okay. All right, so everybody should be looking at the Canvas page for what is population? Okay, do one last check for attendance. All right, if you just logged in, we're in Canvas. We are on the page for what is population. Okay. All right, Tegan, again, don't just log in, participate. Okay, I'm going to go ahead and mark attendance as taken. Okay, so let's look at what is population. All right, so if you remember back at the beginning of the year, we looked at the hierarchy of the biosphere. So again, we started off with a simple organism, which would be one species. And again, we're going to keep on reviewing classification as we go through. So eventually we'll move to higher classifications. But right now we're looking at population. So you come here, you have the definition of a population is the member, and this is the part that's important in that definition. Members of the same species that can reproduce together. Okay, that is what is considered to be the definition of a population. So if you forgot it, write it down. Members of the same, and then this part up here too. They live in the same area, they interact together, and they can reproduce together. They make up a population. So the picture they had up here, this little short video that is a population of penguins. They are all the same species. They all live in the same spot, and that's what makes them a population. All righty. And so then we want to look at what factors can we use to describe population. All right, so we have population size, which is the number of individuals that make up the population. So that was one of the things that you were, um, one more person, that you were looking at in your Muskogee count. Most of you probably looked at what we call the census um, results, and that would tell you based on the census that they did on a particular year how many people live in a given area. So you would be a species, the humans, because they're not counting the cats and the trees and the dogs all in Muskogee County. They're counting the humans that live in Muskogee County is your given area, and then you are interacting with each other. So and somebody kind of quickly put in the chat, what did you find to be the population size of Muskogee County? Somebody real quick put in the chat, what is the population size of Muskogee County? And you should only have to look back at your notes because everybody had to find it. Okay, Imani says she got Okay, so between Imani and Jalen, we have roughly 200 and let's say 10, because she got 206 and Jalen got 216. So let's just say roughly two. And then what year? Do y'all have a year for your statistics? Because that matters. Because we're going to talk about that as well.
It said as of the 2020 census, the population was 206,922.
Okay, thank you. And Jalen, what was your year? And you can do like Imani did. Just come on, unmute, and that's faster than typing, folks. Jalen, you have a year? Because notice there's an increase. So Imani's was in the 2020 census. Um, you don't have a year. Okay. So, so let's just say yours is after, I think that the article I gave you all was 2022. So let's say in 2 years span, you had at least 16,000 more people to join your community. So you want to look at the statistics like that. In this year, we had this size population. In 2 years later, the population had grown to be 216,000. Okay, so um, and if you look at the number that's up on the screen, that's about half the size of the Atlanta population in 2015. And that's 2015. So you know it's grown since then. That was 10 years ago, almost. Imagine that we're almost to 2025. All right. So population size is the number of individuals that actually are occupying that given space at a given time. All right, population density is the number of individuals of the same species in an area. So again, we were not just looking at Georgia, we kind of isolated it down to Muskogee County. This one is looking at the given area being Atlanta, okay? All righty, so we could do a population study of how many people live on your block, how many people go to your school. Would be a population density study. Given area, how many people are in that, not just how many people are in Georgia, but how many people are in a given area. Because, there are places in Georgia where nobody lives. So there's no population there. So if we do an average of everybody in Georgia, we're also not really getting a good picture of the areas where nobody lives. So we break it down into specific areas. So we look at population density. All right, disbursement. Studies the individual, and goes back to what I was just saying, that how is the population spread out? And it can be clumped or clustered. So I'm going to switch to, I want you to take some notes. All right, before I go, so we're going to we're going to take some notes on those things, and then we're going to answer this question as well. So while I'm not going to share well, yeah, I guess I could, because you might be able to copy it better if I share it. All right. Okay, got another person coming in. All right, so yeah, let me give you this, and I'm just going to give it as teacher pace because you're just taking notes. There's no activity with this. This is just like whiteboard. Okay. All right. So I shared the Nearpod number so that you can actually log into it yourself. So these first three, I don't want you to write down because basically that's what we just talked about. I just want you to read them. So they're the same definitions or expanded definitions of what we just looked at on Canvas. So population size, population density, and population disbursement. Okay, so those are our three descriptive factors that we use to describe a population. All right, so again, you don't have to write this down. What I do want you to write down is this. There are three main types of population disbursements. So please write these down and then look at the picture. So clumped dispersion is when the individuals are grouped in patches, often around a resource or social interactions, like for a school area, a school of fish are traveling together, a herd of animals are traveling together. So, but they're in groups like you and your friends. You certain some of you, while you have everybody in the school, some of you hang together, some of you hang in the cafeteria, you hang in the courtyard. You've clumped your group in different areas. So you look at the picture, you've got the population in that given area, but everybody's not standing in the same spot. Okay, so that's clumped. Then you have uniform disbursement. Individuals are evenly spaced, often due to territorial behaviors such as competitions. So that one, everybody's spread out kind of evenly. All right, and then you have random disbursement. Individuals are randomly spaced, usually in environments where the resources are abundant and evenly distributed. Okay. So unlike the even distributed, you got the same number of molecules or individuals, let's say individuals, because that's what we're talking about, but they are not all standing arm's distance apart. They're just standing wherever they want to stand, not in groups. They're just randomly set out. Okay. All right, so take a minute to copy that. And again, look at the picture so that you have an idea of what that is. Okay, I won't move it. All right, hopefully you wrote the title down that there are three main types of population dispersion. So our description, our factors. Okay. Yes, my guy came yesterday. And don't leave out the examples, because those examples are there to try to give you a visual. So I'm sure most of you have seen movies or pictures of fish that swim in schools, and they're all together. But there are other fish in the sea, but this group are swimming together. A herd of mammals, cattle, if you've uh, have certain country areas out in Columbus where people still have cows and stuff. If they're herding, they're all moving together. If they're moving, they're all moving together. All right, uniform disbursement. That mean that they're in an area where the resources are good. So everybody tends to go to the same watering hole. Everybody's in the same area because this is a good shelter for them to be in. And then random, while the resources are good, no, everybody doesn't have to crowd one another. They can spread out, but not spread out in a uniform fashion. There's plenty of food, plenty of water. They're not necessarily hanging out together. All righty. Anybody else need me to stay put? Can I go on? All right. So the next slide again is just the an answer to the question that was on Canvas, because they didn't answer the question for you. They just asked you the question. All right, so on Canvas, the question was, what is the relationship between population size, density, and disbursement? So again, I'd like you to write this down. Oh, okay. All right, so we're comparing all of these things. So density is directly influenced by population size. And the term density means how many um, individuals are there in one given area. So if you have a light density would mean there'd be only a few people in the area. Very dense is a lot of people living in one particular location. For example, your neighborhood, maybe a couple of years, there might have been 5 houses on the block. That's low density. And now they've built more houses, they've built more roads, so the density has increased in that given area. Okay. So the density can be high, it can be small, low, large. So when you're describing density, it's it's always, in terms of population, it's always related to size. And size meaning how many people are in that area at any given time. All right, disbursement patterns can be influenced by density. See, and then we looked at our picture on the other page. how the clumps are dispersed will can be dense. So like we looked at the first picture on our disbursement, then we had like 5 or 6 here, 6 or 7 here, of maybe 3 or 4 over here. So each clump has a different density. So it creates different sizes of patches in the different area. So again, if you look at Columbus, there's a higher density maybe in the downtown area of Columbus. And as you move out from the central area into different neighborhoods, some neighborhoods are more uh, dispersed, some are more highly dense, low dense, depends on where you are. Then if you get further out you get from Columbus, then you have low density. Okay, so size is related to density and disbursement can be related to density. Okay, so together, size, density, and disbursement provide a complete picture of the population dynamics, and that's the word we use, the population dynamics, such as in how individuals interact with each other, compete for resources, and respond to environmental pressures. Population dynamics could be something as simple as more people go to the Walmart than go to Kroger. I don't know what you have in your area, but that's what we have over here. We have Walmart and Kroger. So we looked at the population density and disbursement in just this particular area. Things like that, competition for resources, groceries. And environmental pressures can be simply what's closer, which store is closer. A lot of the people who have cars, yes, they'll go to the one they like, but a lot of times we go to what's closest. So that's an environmental factor. All right, so these factors are key to understanding population growth, survival, and how interactions between ecosystems. So again, I'll leave this here for a few minutes so that you can get that. And that is the answer to the question on Canvas. And when you finish that, go back to Canvas and finish looking that over because that's what I'm going to do as soon as I leave this page. All right, I said when you finish copying this, go back to the Canvas page on population. So this was the question in kind of fancy writing. What is the relationship between population size, density, and disbursement? So just go underneath that and pick up from there on Canvas. So again, I'll stay here for a few minutes so you make sure you get the answer to that question. All right, so again, when you finish copying this, go back to Canvas and continue reading. There is a review quiz at the end of that page. So make sure you do that. And again, just a heads up again, on Tuesday, we are going to do because we're almost to the end of this unit, we're going to do a quiz on everything up to this point. Talk about population. All right, so take note of the words, these terms at the bottom. So we're going to be talking about population growth, population survival. So we're going to be talking about how does number of births and deaths affect the population, and how individuals are interacting within the ecosystem. So what are the resources? Remember, the term ecosystem means it's including our abiotic and biotic factors. All right, we good? All right, so let's jump back to Canvas. All right, so we just answered this question. It also uh, says here, it has an effect on reproduction. So population size is directly related to reproduction. Are there new births in the area? And that may, people mating may determine how many people, what are the chances of you meeting that special someone that you want to mate with and stay in that given area. With people, we tend to move away sometimes, but what are the chances of you finding a mate, staying in that area, and actually having children in that given area, then you would increase that particular population. All right. So we're going to look at the study of birth and death rates of a population. So let's look at this short video.
Calculating the population health involves the birth rate and the death rate to find the
This is
population.
very low, but I do have the volume up as high as it can go.
First, we take the birth rate, which is the number of births within a population during a specific time period, and add the death rate, or the number of deaths within a population during a specific time period. This equals the population size and tells us how fast or slow the population size is changing.
All right, so I want you to write that down. This is an equation. So you have to be able to calculate the population size based on the number of births plus the number of deaths, and that will give you the average population size. So birth rate plus death rate equals population size. And that's all you really need to write. I'm sure you understand that the birth rate is how many people are born in a specific time, and death rate is how many people die in a specific time in that given area. So we are looking, remember, the original definition is population is in a given area interacting together. So the birth rate for that given area, the death rate for that given area allows you to calculate population size.
Knowing the birth and death rates of populations gives information about a population's health. For example, when a population is made up of mostly young organisms, the birth rate is high and the population is growing. If a population has equal birth and death rates, it will remain the same. However, populations that are decreasing in size have a higher rate of death than birth.
All right, so we want to look at factors. So you want to make a little heading of factors that affect population size. So you said the age of the population. So if you have young people, then they're going to be reproducing, the population will grow. If it's an older community, the population will probably remain the same. Yes, there will be. Also, it can remain the same if there are an equal number of births and deaths. So this would be a mixed community. You have young people and old people. So you have some people dying, you have some people being born. So that would be a mixed population. Okay. And you have a population that might be decreasing, where everybody in that area, nobody's moving into the area, nobody's having babies in this area. And as people die off, the population decreases. Okay, so these are three ways to describe what is happening in your area or in a particular area.
Right.
All right. And this is in Canvas, so if I ended that too soon, that's something you can go back and pull up for yourself. All right, so I want you to take a few minutes to do this matching activity. So let's say 10 minutes. And you might want to write this down, because I'm going to take this particular patch right here and add it into the test. So let's take about 10 minutes and work on making sure that you have this one down pat. If you finish before the 10 minutes is up, make sure that you do the review before you go. And if you've done that, go on to the next one, the next module, because we're going to try to do a little bit of that as well. All right, I'm going to stop sharing for a minute because I need to. Jaquise, it looks like you are having some internet issues. Not, all right, I need to adjust the attendance. All right, so everybody should be working on the drop down section. Again, that section will be on the test. Okay, so again, this is kind of like a vocabulary quiz, so please make sure that you have um, that your answers match. And then we'll go on to demographics. All right, so for demographics, we need to be able to read a graph because it's all about that's why we got graphy in there because we're going to be reading graphs for demographics. So you have to always understand there's usually three factors that they're color coded most of the time. So this one not only has the population going up your y-axis, it has over the period of time. So this one is in years, and then they've color coded it to be different places in the world. Okay, so questions. So you would get a graph such as this, and they would ask you, for example, what is the population size in Europe in the 1600s? Okay, that's not even on there. So let's say of Europe in the 1800s. Okay. So based on this graph, and so somebody type in the chat for me. Based on this graph, looking at this graph, what would be the approximate population size in Europe in the 1800s? And this is how you would go about reading this script. That would be a question. So you have years, you have kinds of people, and you have an estimated number. And these numbers, all right, so Ethan says yes. So it's a little less than 1 million. Okay, so thank you, Ethan. About 500. And a lot of times we're guesstimating with this, okay? So you kind of have to take a ruler and guesstimate where, but it's pretty low. It's kind of like halfway between 1 million and 500,000. Okay? So and this particular one is humans, but it could be whatever we're studying. Like I said, it can be how many pine trees are in a given area, how many cattle are in a different area. So it could be any type of organism would be represented the same way. Okay. And when you want to compare different populations during the same time, they do like what they have here. They color code the graph to indicate the difference between individuals without creating 5 and 6 graphs. Okay. All right. So you have a new word here, demography. Okay. All right. So somebody who studies demography are demographers, and they make a life like our census takers take this information and they bring it to a demographer who is studying the population of a given area over a period of time. They might start from when was the town formed, and between when the town was formed and where we are today, what was the shift in population? Has it grown? Has it decreased? So these are the kind of people who study this. Okay, so when we're studying this, we're looking at we tend to look at developed countries opposed to developing countries. So those are two terms that you need to get familiar with. A developed country has a high average income. So the United States is considered to be a developed country. Slower population growth, diverse industrial economies, and stronger social support systems. All right, developing countries have lower incomes. So those are smaller countries that don't have a lot of industry going on. Okay, I'm sure if you do social studies, you've also talked about developed countries and developing countries. All right, so there's a difference in the growth patterns. So this is a factor that you have to look at when you're looking at growth patterns in populations. All right, so again, we have our um, definition. So again, we have a graph, and in our graph for birth rate, we have the percentage or maximum life expectancy. So things are not expected to live forever, and the number of individuals surviving. So this is what this particular scale is. So what does this graph say to you? If you're looking at,
You're not sharing.
oh, I'm sorry. Thank you. And I guess I should be. So hopefully everybody is on that page though. Okay. Thank you, Imani. Always keep me on my toes. Okay. There we go. All right, so let me back up a bit. So so again, hopefully you're on this page. Everybody's on this page. And I was referring to the two definitions between developed countries and developing countries. All right, so we're going to look at two factors, the birth rate and so let me come out of that for a minute, birth rate versus death rate. So when we click on the little question mark, it gives us a graph. I said birth or fertility rate. So they call this a survivorship curve. So that's a term you need to become familiar with, a survivorship curve. All right, so just looking at this graph, and I can't make it bigger. What does this graph tell you? So you got to pull all of this. And I wish so before we even look at that part, don't cheat. What does this tell you? So we have three different things. We have trees, we have birds living in this particular area. And so these are three different populations. Remember, populations are the same species. So this graph is showing you three different populations: the human population, bird population, and trees. And they just happen to be all in this same area. Okay, so they can put them on the same graph. All right, so what is this? Just looking at the graph, what are you, the percentage of maximum life expectancy? Who lives the longest? Whose life expectancy is the longest? Just by looking at the picture. So everybody starts off good. Who just by looking at the picture, who lives the longest? Who has a maximum life expectancy that's almost goes to 100? The humans, not the birds. The birds kind of go downhill real quick. The humans have according to this graph, because it goes pretty it goes pretty constant for a long, long time. And then notice it drops down kind of at about 75, and then it just kind of tanks as it gets to 100. Trees, they're very hardy way up in the beginning. And after about 50, by the time you almost, I wouldn't even say 25 years. At 25 years, there's a decline almost to, they don't make it past 50 or most trees. You have some real ancient sequoias out in the west, but most trees, according to this graph, don't have a maximum life expectancy to 100 years. And the birds, they come and go very quickly. All right, so let's pull this up a little further. All right, so we're going to look at the fertility rate with the number of births per 1,000 women of childbearing years. So we're looking at the human population. And then the replacement level is average number of children that each parent must have in order to replace themselves. Okay, so you've got huge, that's true. And Ethan said, not as quick as butterflies and caterpillars. They don't live long at all, at all. So it does depend on the species. Different species have different, so you can't just put a chart up there. You have to describe who you're talking about. So that graph showed you 3 different populations and how different their life expectancies are. All right, so take time to go down and read these. All right, so we have a group of people we call type 1, most people who live to be very old. And you'll find this in the developed countries. In undeveloping countries and underdeveloped countries, we have a high death rate. A lot of the countries have high infant mortality rates. So they're having children. So the birth rate is high, but the mortality rate is even higher. So they kind of don't increase the population because the death rate of the children are not living long enough to reproduce. Okay. Type 2 are populations that have similar death rate at all ages. So you have there is some young people dying, like we said, we have people dying in childbirth or babies dying at birth as is equal to the number of older people dying. So the population kind of stays about the same. And then you have a population where many children die. So that's what I was saying. Some of the underdeveloped countries that don't have, where the people are not healthy enough. So they're having children, but the children that they're bearing are not healthy enough to survive. Okay, so that's that one. All right, so it says type 1 and type 3 may result in populations that remain the same size or grow slowly. Okay. All right, so type 2, you're going to have some fluctuation a little bit. All right, so let's look at death rate. All right, so again, they have a map. And again, with this particular unit, you're going to have maps and keys that you have to follow. So you want, and I wish I could blow that up, but you notice that the lighter areas are going to be low death rates and the darker areas have high death rates. Okay. All right, so you scroll through this, read, there you go. So life expectancy is affected by infant mortality, that's vocabulary word, which is more affected by the parents' access to education, food, fuel, and clean water. So those are our abiotic factors. Do the parents have access to things, except for the food might be biotic? Do the parents have the ability to provide the infants with the resources they need to live a healthy life? And if they live a healthy life, then their life expectancy can be greater. But if the parents are malnourished to begin with, then they create children who are malnourished. And because they are young, they have less chance of surviving. All righty. All right, so something else. So I said this is very typical of herds. This definitely does not apply to plants because plants are stationary. They don't go anywhere. But this is humans. We can get in our car and decide we want to move to Alaska. We want to move to California. We like the weather better in Florida. So we can migrate. Some people might like the fact that Georgia weather is better, not as hot or not extremely cold. So they immigrate. So you need to population density is directly affected by who's coming into the population and who's leaving the population. All right, you had this equation before on the other page with the video. And this is just a more complicated way of looking at the population size. All right, so not only do you have birth rates, but which is one way for new individuals to come into your population, but now you also have to consider people who have moved into your population, okay, as opposed to death rates, people dying, and incorporating those who just left voluntarily from your population. So copy this equation as well, and the information that explains the formula. So we wrote down the first equation at the top, which was just simply birth rate plus death rate. And now we need to add immigration and migration to equal population size. And then we want to break it down a little more. Can I get all of this? Okay, yeah, I can do that right there. Okay. So before we just said birth rate, death rate is equals population size. Now we're incorporating immigration and emigration as a factor that affects birth rate. And we're lumping birth rate and immigration together and death rate and emigration together. And again, these go under factors that influence population size. All right, so we only have a few more minutes left to class. So once you finish looking at that, actually, we're going to stop. Let's stop it right there. All right, we'll look at those other graphs later. So again, Tuesday, no school on Monday. Tuesday, expect a quiz test. And we're going to talk about population and a few of the other things that we did up to population. So this, including this, factors which affect population, um, all of the vocabulary, population density, growth, and let me pop out of this for just a little bit. Okay, it's easier to do it this way. So we're going to stop there at that point in this unit, but okay. So yeah, just that one. All right, so be familiar with the information from this page and this page. Okay. All right, so I'm going to stop right here again, and hopefully you have your Canvas open, so you really don't need me to stay put. But um, once you finish writing that down, you are free to go. And you have a great weekend. Be safe.